Good morning, all of you. In this session, we are going to start with the 10th class chemistry and physics. So here, unit 1, reflection of light on curved surfaces is going to be discussed now. Okay, so this kind of discussion will fetching you towards cracking the examination with a good score, and it will help you for the preparation towards your 10th class examination. Let us go with your today's topic. So earlier we completed in this unit 1, series 1 was completed. So in continuation to that series 1, we started with the series 2 of the session. So here, what is a normal in a concave mirror? We are going to do the experiment by using this concave mirror. Concave is a parabola structure where spherical mirror was taken. In this, how can we identify the normal? For that purpose, we are doing this experiment. So from the center, we are going to point up point C. So this point C, we are going to draw the hypothetical line, which is said to be a line called the center of curvature, right? From this point C, if hypothetical line was drawn from this parabola structure, which is called a concave mirror, and that is said to be a center of curvature, which is also known as principal axis of this mirror, right? So when we are drawing the pointer from this parabola, that gives the normal at that point. These dotted lines are indicated as the normals in this point, and here parabola is assumed to be a part of a sphere, and C is the point where principal axis is going through that, and P at which point it is intersecting with this mirror is said to be a P, that is given by pole, right? Now let us see reflection of light in this sphere. So we are going to draw one more line which is parallel to this center of curvature. Center of curvature denoted with C. In the similar manner, any other parallel line was drawn, that is called R. R is the ray incident angle. So this R, through the R, that light is allowed to pass on the curvature called the parabola structure concave. So light from the source is allowed to fall on this. So here there is a generation of normal. Normal is generated, and here that is said to be, this arrow is indicated as a incident light that used to generate certain angle, which is denoted with I. I is called incident light angle. And after bouncing on this parabola, light is reflected with certain angle. That angle is said to be R. R is nothing but reflection angle. In accordance with first law of reflection, incident angle and this reflection angle both are equal, identical. So that is nothing but I is equal to R. So this is a normal what we are going to draw from this point R, where the source of light is allowed to fall on the parabola structure. The midpoint, geometrical center, you can say this is a geometrical center. That point is called pole P. So when this center of curvature is bisecting with this parabola structure, that point is said to be P, called pole of the mirror. Horizontal line shown in the figure, which passes through the center of curvature pole, is called a principal axis. Hypothetical line drawn is called the principal axis. So here P denotes the center of curvature, the line denotes the principal axis of the mirror. Distance between P and C is called radius of curvature. So here P point, which indicated on the mirror curvature, C point indicated from this mirror in the certain distance. The distance between these PC points denoted with capital R, which is called a radius of the curvature of the mirror. This is denoted as a radius of the curvature of the mirror, right? So these are the few interference which are drawn from this experiment. What experiment we are drawing? We are taking parabola structure, which is called a concave. On this concave, point C indicated called center of curvature. Point P indicated pole of the mirror, and any other parallel line was drawn, which is indicated with R, and here the light source was bounced on the mirror, and after bouncing, that will be reflected with the angle R. In accordance with the first law of reflection, I is equal to R. right? So this was completed. This is the experiment. Now another experiment we are going to do. We are taking two thermocol boxes. On these thermocol boxes, two parallel pins were placed. Okay, so these pins should be perpendicular to the box. So two parallel pins were placed on two different thermocol boxes, and these thermocol boxes are kept in distance with this candle, right? So candle light is allowed to fall on these pins so that they are used to give its a shade. Now let us see what is the experiment and what is the interference experiment. First, we need to create the situation in which one gets a parallel rays of light. In order to get the parallel rays of light, so we are pinning these two pins on this thermocol shown in the figure. So we have stuck two pins on the thermocol block. So two parallel pins were placed here. Pins are parallel to each other, and source of light kept very near. Source of light is there, that is very near to the thermocol box. We see the shadows which are diverging. So when you see the shadow, both shadows are not pointing at one unit distance. Both are diverging, both are deviating from each other. So this is said to be a diverging shadow, right? From the base pins, they are moving in a certain distance, certain angle, they are moving away to each other as we move the source away. So in the first case, what we did with respect to this thermocol box, this light source was kept very near, and you can observe it's a shadow. So that shadow is observed as a diverging light. Now, what we are doing, we are moving this light away from the box, away from the thermocol box. As we are detaching, as we are increasing the distance of this light from the mirror, light from the thermocol box, what happens? Parallel shadow, but we move candle away, the light intensity becoming low. So as it is moving away from this one, what happens? Its intensity will be lowered. As the intensity becoming lower, as intensity diminishes, and beam of parallel light source beam longer distance, it must be sufficient intensity. Up to certain distance we have to move, up to which that able to give the shadow on its surface. So in that way, you are going to draw that light away from this thermocol box. In the first experiment, the light source is sufficient distance with respect to thermocol, and that used to give the shadow with a divergent light. In the second case, we are slowly moving away from that, and the shadow intensity will be slowly lowered. At the maximum distance, you have to place this candle so it used to give the light shadow. After that distance, you are not able to get. Up to that distance, you have to drag it later. So what you can observe, what do you find in this? Yes, we have one easily available source. You probably have guessed it, the sun. So can we find such a kind of inference in our daily life? This is the experiment. Is it possible naturally? Yes, it is possible by using sunlight. So sunlight is falling on the objects. You can see your shadow. That is also purely because of this reflection of light only. Hold a concave mirror. We are going to do the experiment. Activity 2. What? So here, sunlight and concave mirror experiment we are going to do now. Sunlight and concave mirror. Hold the concave mirror such that sunlight falls on it. So concave mirror was taken, that is inverted curvature was taken, and what you are doing? So sunlight is able to fall. So we are not taking any radiation source. Directly we are allowing sunlight to fall on this. Take a small paper, slowly move it in front of mirror. A paper was taken, and in front of this mirror, that paper was kept, and slowly it is moving towards the mirror. And find out point where you get the smallest and brightest spot. So when that paper, that paper is used to reflect the light, and at which distance that paper is giving the brightest spot of the sun, brightest spot of the sun, that you have to notice. Okay, so what is the activity we are doing? We are taking a parabola, nothing but concave mirror, and light rays. This concave mirror was arranged in such a way where light rays are allowed to fall on its surface directly, and one of the paper was kept in between, so that So that used to give the image of sun upon that. Image of sun was kept, that shadow was collected on that paper. So you have to adjust the paper in a such a way where you are getting smallest image of the sun and the brightest spot of that one. In that manner, you have to adjust that paper by changing its distance from that curvature, from that mirror. Okay, so this is the activity. Then after doing this, draw a parallel lines. So from the center of curvature will be there, and this line is called principal axis. With respect to this center of curvature, you are going to draw the parallel lines. Parallel lines were drawn with respect to this center of curvature. So after drawing that, light rays are allowed to fall on the parabola and converge at the point. So being it is the concave lens, what happens always? Light rays will be converged. Converged nothing but they get united at particular point. At which point you can see that kind of convergence? At a point C called center of curvature. At that point, all the light rays got united, right? So now the distance from this convergence of light to the parabola structure, that is said to be a focus, which is also known as a focal point. Focal point is nothing but the distance between the convergence of light and to the mirror or lens, what we are taking called a concave, right? So that distance, that minimum distance is said to be a focus or focal length or focal point. Now one more point we are going to discuss called focal length. Focal length is nothing but the distance from that focus or focal point to the mirror. That distance is said to be a focal length, denoted with F, right? The radius of curvature will be the twice the distance of a focal length. So radius is nothing but the distance from the one into any other end, that is a twice always with respect to this focal length. That is nothing but radius is equal to 2 into focal length. That is the relation between radius to focal length. What is meant by focal length? So when this parabola was taken called concave lens, which allowed to incidence of the sunlight. So what happens at particular instance, all the light rays get converged, all light rays get united. That point is said to be a focal point. The distance from the focal point to the center of this curvature is said to be a focal length. So always the relation between focal length and radius will be r is equal to 2f. So this will be the relation. Now what will be the conclusion? What happened if you hold the paper at the distance shorter than the focal length? When the paper adjusted in such a manner where the shortest image and the brightest image observed, then only you can easily find out the focal length. Now, what we are doing, we are shifting the paper less than the focal length. So less than the focal length, the mirror, and move it away. So we are shifting its position. What happens? Does the image of the sun become smaller or bigger? You will notice that image of the sun first keep on becoming small. As we are moving towards the parabola, what happens? The size of the sun will be slowly concising, right? So, and after particular instance behind the focal point, if you are moving that point away from the focal point, what you observe? The sun diameter will be enlarged slowly. That is nothing but, so below this focal point, if you are moving towards the lenses, what happens? Size of the sun will be lowered, and conversely. So if you are moving that paper away from the focal length, size of the sun will be enlarged. This can be applied to any light source what we are applying here, right? So this is the conclusion what we drawn from this experiment. Sunlight with respect to concave mirror, right? So from this, figure 5, we are taking same experiment we are going to perform with convex lens. So till now we observed with concave lens where curvature is there inside, nothing but parabola structure is there and the convergence of light will be there. Now we are going to perform the same experiment by replacing concave with a convex lens. Convex lens where the light rays are falling on the surface, which is called hyperbola, right? And here curvature will be bulged one, that means enlarged one towards outer surface you are going to perform the experiment. And light rays are allowed to fall on the outer surface of this curvature, which is said to be a convex lens. And always convex lens is used to give the divergent light after the reflection. Light will not be focused inside, light is coming out, and this is called a divergent light after the reflection. If we extend the refracted rays backward, they meet the point F. F is nothing but focal point, right? So focus of the convex, right? So in this manner, this center of curvature will be appeared inside. Now light rays are allowed to fall in the outside, so that here divergent light will be observed. That is clearly indicated in the figure 5. So this is the experiment in between sun and a convex lens. Convex lens originates divergent light, concave lens originate what? Convergent light. Here the focus point is indicated inside the mirror, and that whatever we are getting called a focus or focal point, that focal point, if we are shifting the mirror, if we are extending the reflected rays backward, a focus of the convex mirror, what happens? That size of the image will be lowered, size of the image will be diminished. Always this convex mirror used to give the image of the object smaller than its original one, right? So that is the conclusion we drawn. Now there is a question for thinking, higher order thinking. See the figure, a set of parallel lines falling on the convex mirror. What conclusion can you draw from that? Will you get a point image if you place a paper on the focal point? When parallel rays are incident on the concave mirror, reflection, they meet at the focus. Okay, so different parallel lines were drawn. All different parallel lines are used to meet at the point called the focus point. And what you get the point image of the place, a paper and the focus point? Yes, we will get, but the diminished size, smallest size of the image will be obtained, right? So this is about the 10th class chemistry and physics, unit 1, series 2, where we discussed about sunlight and concave lens, sunlight and convex lens. Thank you very much for your patience listening. Hope this session will be helpful for your further preparation. Thank you one and all.